All right, so the first step in making your cross-sections model is deciding what you're going to make. I decided to make a Pokeball, mainly because I have 3 young boys who are obsessed with all things Pokemon. I started with just information about my Pokeball. And I Googled and found the actual dimensions of an actual Pokeball. And I did decide when I actually made my model to scale it up. But before I did that, I went ahead and created a base model. So I took my diameter, which was 2.5 inches, and I centered my Pokeball at the origin. So that created here this radius of 1.25. I split the model in half so that it would be in fact a function, and f of x representing the top half of the Pokeball and g of x representing the bottom half. Now once I did that, I knew I was going to need to figure out the actual size of each of my cross sections. So first I needed to decide how the mathematics would calculate the areas of each of the cross sections. So I recognized that given my f of x and g of x, that one cross section would be a semicircle with the diameter being the difference of f and g, right? So that means my cross sections will go this direction, right? Perpendicular to my x-axis and popping out of the screen at me in this 3-dimensional manner. So in order to get the radius of my cross section, I know that is half the diameter. And in order to get the area of a semicircle, it is 1/2 pi r squared. In this case, I did not include the 1/2 because I was calculating the area of the true Pokeball. But for my actual cross sections, it will be 1/2 of that area. Okay, so then using that information, I open up an Excel spreadsheet. And I'm simply going to tell Excel the information about my Pokeball cross sections. I'm going to start with the headings X, f of x, g of x, d of x, r of x, and a of x, and v of x. And now I'm simply going to tell Excel the information. So my first cross section began at negative 1.25. So I'm going to put that as my first x value. My f of x function was equal to the square root of 1.25 squared minus each of my x values squared. So I'm going to tell it that. My g of x was equal to the negative square root of 1.25 squared minus my x value squared. And you'll notice when I say x value, I'm selecting the correct cell for that x. My diameter was the difference of these two. And then my radius was 1/2 of the diameter. And my area was 1/2 times pi. I'm going to just approximate it, times the radius squared. And my volume was equal to the area times the thickness of the material that I'm using. I chose to use a Dollar Tree foam board, which was 3/16 of an inch thick. Now you will notice that all of these are 0, and the reason they are is because this is the first point at which my functions exist, meaning the thickness between them, because they are equivalent, is 0. Now I need to tell Excel where the next cross section begins. And it will start from the previous one plus the thickness of the board. So I will add that 3/16. Now here's where the magic happens. I'm going to take all the formulas from before and I'm going to drag them down. Now what this does is it gives me the function values, it gives me the diameter, and it gives me the radius and area of this next cross section. Now I'm going to take this entire row, I'm going to highlight it, and then in the bottom right corner, I'm going to see a plus. And I'm going to drag that plus down, and it's going to fill in the formulas. Now you will notice anything past that 1.25 is going to come out error because my function does not exist beyond that. So I'm going to delete those. Now you will also notice a couple of things. You will notice that it's not perfect, right? Because we have specific dimensions, but our cross-section material does not necessarily fit that dimensions perfectly. So we're going to get as close as we can. Now that you have this, the rest is easy. The column you want to focus your energy most on is likely going to be your diameter column. This column tells you the diameter of each of your semicircle cross sections. So using a compass or using something like Microsoft Word, use the shape editor to create circles with these given diameters, or set your compass to the correct radius and draw your circles by hand onto your material. That's pretty much it. The rest is cutting and decorating. Have fun.